Okay, the next example we're going to look at is going to be example 3.6. So here again, we're going to be determining the resultant, but this time we're going to be adding together four vectors, and the vectors are A, B, and C. You're going to find the vectors that we're going to be adding on page 50 in your book, example problem 3.6. We want to graphically determine the combined effect. So again, we want to determine what the resultant is of these four forces. So the first thing we're going to do is we're going to draw these at the angle that we see them at and the size. So the first one here, A, is going to go straight up at 90 degrees, 200 units long. Then we have B. B is going to be 226, but this one, because it's an angle of 15 coming from 180, remember when we input our angle from 0 degrees, it's going to be a counterclockwise to our vector. So this one would be 180 minus 15. What would that number be? 180 minus 15 degrees.
165.
165 degrees, okay. And then the other ones are going to be from 0. So go ahead and draw each one of your vectors and label them A through D. And I will do that in the background here. Don't forget to use your at symbol when it's a relative value. Okay. How's everybody doing? Awesome. Good. So first step is always going to be drawing the vectors as we see them in the problem. Now what we're going to do is I did create my vector equation. You always have to have a vector equation on your problem. So my resultant, my combined effect, my resultant is going to be R, capital R is equal to, and we're going to add it in alphabetical order right now, A plus B plus C plus D. Okay. Now, as we look at our equal sign here, our first vector is A. So I need to put my origin at the tail of my first vector. So I'm going to put it down at the origin of A here. If you want to get rid of this X and Y axis, it kind of is irritating to me. You can go to insert. And if you go down, no, it's not insert. Where is it? Shoot, is it annotate? No. View? Yes, view. Sorry. It's on the view tab. And you can just turn off that UCS, okay? Sometimes it kind of gets in the way. And it's not really needed. Okay, so now I'm going to put my origin here. And all I'm going to do is, an origin is just that crosshairs. It just has to be large enough. It doesn't pay putting it on a start file because you're always going to have to scale it. And since this is going vertical, I wouldn't do a vertical origin, but I just have to know where I'm starting. And as I said, the equal sign is like the origin. So A is my first vector. At the end of A, at the tip of A, I'm going to put the tail of B. So I'm going to move my vector B. Its specified base point is going to be its tail, and I'm going to place it at the end or the tip of A. Then I'm going to add C to B. So I'm going to move C, tail goes to the tip of B. And then D, its tail, is going to go to the tip of C, or the last vector, right there. Okay? So A plus B plus C plus D. Notice there are no tips together or any tails together. It's tip to tail, tip to tail, tip to tail. Okay? Now that I've exhausted all of the vectors on the right-hand side, I'm going to cross over the origin. So that means my tail of my resultant is going to start back at the origin. I'm going to change my layer to object 2. I'm going to draw a line from the origin to the tip of the last vector on the right-hand side, which is the tip of D. Now at the tip here, this is going to be where the arrowhead is for my resultant. So I'm going to add a line. I'm just going to make it longer again because it's the resultant. It's kind of the answer to our problem. I'm going to copy one of the letters over. I'm going to just grab A, and then I'm going to label this R for resultant. Okay. Wouldn't hurt to do a quick save, example 3.6. Okay. And now let's just kind of review what we have. We have our equation. Okay. So you always have to put that in. We have an origin. We have each one of our vectors labeled, and each vector has an arrowhead. Now for my answer, what is the magnitude and direction of the resultant? I'm going to change to my notes layer. I'm going to add an aligned dimension. Okay. If this was vertical or horizontal, I could use a linear dimension, but I need it to be aligned. Make sure you go from endpoint to endpoint. And you're not going to see the actual number because it's really small. So now what we're going to do is we're going to go over to our Annotate tab. We're going to open up that Dimension Style Manager box, modify, go to the Fit tab, and change this to, I think it's about 100. We'll see. Set current, and then close. That's pretty good. Now, if we glance at the book, you're going to notice that the book has, to no decimal places, 521, okay? Our dimension, our actual dimension came out to 520.69. Rounded up, that would be 521, right? Okay, so we're good. Then we're going to do our angle. Go back to home, change our dimension to an angular dimension. From horizontal, I picked the origin horizontal line to our resultant, and I'm going to leave it right about there. And you should be at 69 degrees. The book says 68. As long as you're within a degree of the answer, I'm okay. So if you would be at 67 and 60, between 67 and 69, you're fine. Okay. If it's more than a degree, then you got to go back and look, what happened. Okay. Because you should be pretty darn right on. All right. So now we have our resultant magnitude identified. We have our angle that it's at, and we have the arrowhead on it. So we have fully defined magnitude and direction for our resultant. Now what we can do is we can take our screenshot of this second example to add it to our Module 3 application problem, or Module 3 practice problems, okay? Any questions on the second example? All right. If not, then I'm going to stop the recording here.